Okay, so today we're going to talk about factor trees, prime factoring, prime factorization, and how we can use this information to help us find the greatest common factor and the least common multiple. So, to start off with, let's work on the factor trees. So, we have two numbers here, 36 and 27, and we need to find the factors of each number. Let's start with the 36. So, basically, with factor trees, you always do two branches coming off each number. And what that represents is two numbers that will multiply to give you the top number here. So in this case, I could choose a few options, but I'm going to choose 6 and 6 because 6 times 6 would give you 36. Now, as you'll notice, neither of these are prime factors. They're both composite numbers. So for 6, that can be broken down into two more numbers that multiply together. Those numbers being 2 and 3. This 6 also breaks down into 2 and 3 because 2 times 3 is going to give you 6. So now 2, 3, 2, and 3 are all prime numbers. So we can't break them down any further except for 1 in itself. And there's no point in doing that because you could basically make the tree go on forever if you kept doing that. So we finished factoring down 36. Now, let's look at 27. So if we break this apart, what are two numbers that can multiply together to give you 27? Other than 1 in itself, I believe the only numbers that can do it are 3 and 9. So when you have this, 3, as you'll note, is a prime number, so you don't need to break it down anymore. 9, however, is still a composite number, so you still need to break it down. So it can break down into two more numbers, which are 3 times 3. So now you've got all prime numbers at the bottom of the factor tree on this side and at the bottom of the factor tree on this side. So when we're doing our prime factoring, we can look at what are the prime factors of 36. So 36 has the prime factors, and I always like to put these in order from smallest to largest. So we have 2 right there. We have another 2 right there. We have 3 right there, and another 3 right there. The number 27 has the factors 3, 3, and 3. So it's important that you write this down in the number of times that these occur. So there's 2 2s and 2 3s in this one. So 2 2s and 2 3s, and 3 3s in this one. So 3 3s right there. Now, prime factorization is almost the exact same as prime factoring, but there's one little difference. With prime factorization, it's actually written as a multiplication. So 36 is equal to 2 times 2 times 3 times 3. We're using those exact same numbers as we're using here. You just write it with the little equal signs and the multiplication symbols. Now for 27, you write 27 equals 3 times 3 times 3. Now we've done our prime factoring and our prime factorization. So how can we use this information to help us find our greatest common factor and our least common multiple? Well, I find the easiest way to do this is to go back to the factor tree. And what you want to do is match up any of the factors that are the same in both trees. So in this case, I've got a 3 here and a 3 here. So I'll circle both those. I've got a 3 here and a 3 here. So I'll circle both those. Now, after I've made those, there's no more common factors between those two trees. So I just underline the remaining numbers. So there's an extra 2 here, there's an extra 2 here, and there's an extra 3 here. That information is all going to be useful. You can still do that here, of course. So, for example, you could circle the 3 here, and the 3 here, and then the 3 here, and the 3 here. Either way will work, and then I would underline my 2's and my extra 3. So you can do it in either place. I just like to do it on the factor tree. I find it's a little bit easier to follow. So how does that help us find the greatest common factor? So the greatest common factor of both 36 and 27, basically all you have to do is times these the circled numbers together. So we have a pair of 3's here and a pair of 3's here. So there's basically 2 3's that are common to that factor tree. So 3 times 3. Because remember, these numbers are common and those numbers are common. So each one of those, so I put one of those common numbers here and one of those common numbers here. So 3 times 3 is going to give us 9. So you'll find that the largest number that is a factor of both 36 and 27 is going to be the number 9. Now, how can we find the least common multiple? Well, this is why I really like to stay with the factor tree. What you do is you use the leftover numbers, so the underlying numbers. So in this case, I'll start with the underlying numbers on the left factor tree, the one for 36. And so we have a 2 times a 2. And then you times those numbers by the main number of the other factor tree. So in this case, 27. And you'll find 2 times 2 is 4. And 4 times 27 is 108. Now, if you want to, you can actually double check that this is correct, because it should work that it goes the other way as well. So if I use the underlying numbers on the factor tree of 27, all I'm going to have is a 3. And then that multiplies by the head of the other factor tree, which is 36. So 3 times 36. And if you do the multiplication for that, you'll find that that leads to 108. So it doesn't matter which way you do it. And it's actually a really good technique to double check that you got it right. But 108 is the smallest number that these two have as multiples, or the smallest multiple that both these two have in common. And 9 is the largest factor that both of these two numbers have in common. So now we've learned about our prime factoring, our prime factorization, our greatest common factor, our least common multiple, and the way that we can do that using factor trees. I hope this is helpful.